Good afternoon, everybody. So we're in the string notebook, which is really just parameter substitution, right? So everything that I'm talking about is just some variation of parameter substitution. Remember that in Bash, all information is in the form of a string of some kind. So when you're accessing the value of a variable, basically you're accessing the contents of a string. There are numerous ways that you can manipulate or change the information that you're accessing in a string. So we saw some of them in the last lecture. Right, so we saw replacing the front part of a string if it matches a pattern. We saw replacing the end of a string if it matches a pattern. We saw replacing substrings. I think the last one I want to talk about, well, there's also case conversion. I'm not sure if I'm going to do the next part or not. So case conversion lets you convert either the first letter of a string, you can convert its case, or you can convert every character of a string. You can change its case. You can also do this conditionally. So the way that this works using a parameter substitution is that you're still specifying some pattern. So comma lets you replace the first character of a string to lowercase. The caret lets you replace the first character of a string to uppercase. But the case is changed conditionally. Right? The case is only changed if the first letter matches that pattern. And similarly, the case is changed to uppercase only if the first character matches that pattern. Right? So it's not simply change the first letter to uppercase, it's change the first letter to uppercase as long as it matches some pattern. So, for example, we have the string ABC, right? All caps. If I want to convert the first first letter of the string to lowercase, so I want to make it lowercase a, uppercase BC, you can do it using the comma in the parameter substitution. So here, that's our parameter substitution, right? So I'm going to look at the contents of string, replacing the first character of the string with its lowercase version as long as the first character is an A, right? So here my pattern is that, right? And the pattern must match exactly, right? Which is a bit weird with this substitution. So that one works. So number one should print out lowercase a followed by BC, right there. Right, so that does what we were hoping it to do. Now the second one looks like, so it looks like the user wants to replace the first, wants to change the first character of string to lowercase as long as the first character is one of A, B, or C. Or possibly, the user means replace the first character of str with the lowercase as long as str starts with ABC, right? In fact, it doesn't mean either of those, right? This is the pattern, ABC, right? And so if the first character is equal to ABC, then replace the first character with its lowercase version. So the first character, of course, is not equal to a string, right? It's a character. So this one doesn't do anything, and which is very strange. Right? So there, the original string is unchanged. Right? If you mean replace the first character, if the first character is an A, B, or C, you have to use the square brackets. Right? So remember, this is these types of patterns are the exact same patterns that you'd use when using a wildcard for matching file names. So square brackets, stuff inside the square brackets defines a class of characters. Right? So this will match either the uppercase A, or the uppercase B, or the uppercase C. Right? So as long as the first character of the str is one of those, change it to lowercase. And so it does, because the first character is uppercase A. Right? Remember what the question mark means as a wildcard pattern, right? The question mark means match any character. So this will always replace the first character with its lowercase version. Right? And if you leave off the pattern altogether, Bash assumes that you mean Bash assumes question mark, right? So that also always replaces the first character of the string with its lowercase version. So back here, remember the A is the pattern. So if you change that to B, the first character does not change to the lowercase, right? Notice the B doesn't change either, right? The single comma and the single caret only replace the first character. Exactly when you would use this, I'm not entirely sure. I couldn't come up with a use case for this, or at least not a common use case for this. But it's there if you need it. The uppercase version works the exact same way, right? So that's your pattern. The single caret means replace the first character with its uppercase version, right? So if the first character is lowercase x, replace it with uppercase x. Right? This never replaces the first character because the first character is never x, y, z, right? That replaces the first character as long as the first character is one of u, v, or x. Right? Again, the question mark means always replace. If you're missing the pattern, again, it means always replace. So this is the exact same thing as before, except now the x changes to uppercase x here, and 3, 4, and 5. Right? Now, if you want to change all the letters in the string according to a pattern, that's what comma, comma, and caret, caret are for. Right? So comma, comma, replace each character, attempting to match each character to that pattern. Right? Again, that's the weird part, right? You're going to try to match the character, every character to the pattern. And replace the character with its lowercase version here, uppercase version if it's caret, caret. So here's my string ABC, XYZ. So comma, comma. Right? So try to replace each character with its lowercase version as long as the character matches uppercase B. Right? So of course this is going to replace that B with the lowercase b. Right? Here's the weird one again. Right? You're going to match character by character in this case. So a single character never matches the string ABC, XYZ. So 2 never doesn't do anything. You can specify a range. Right? So replace A, B, or C with its lowercase version. Right? Question mark again, match any character. So replace every character with its lowercase version. If you're missing the pattern, again it assumes a question mark. Right? So the first one should only replace the B. Right? The second one should not do anything. Right? Because a single character never matches a string of length 6. Right? The third one should replace the A, B, and C, and it does. Right? The fourth one should replace all the characters with their lowercase version, and the fifth one should do the same as the fourth one. Right? And I didn't go the other way. So again, if you want to go the other way, so convert everything to uppercase, just use caret, caret instead. All right, there's a bunch of other conversions that you can, not conversions, there's a bunch of other variations of these substitutions that you can perform. Again, I'm not going to cover them in this lecture or in the notebook. There's a link at the top of the notebook to the documentation if you want to see the other things that you can do with parameter substitution. I guess we should talk about this. So the fact that Bash Bash creates a variable for you when you first use it, can often do the wrong thing, right? So, for example, it might be important that you know that a variable is unset or is the empty string. And so there's a bunch of parameter substitutions that let you deal with, or they do something different if the variable is unset or if it's equal to the empty string. So there's a whole bunch of these, right? Again, don't memorize these, just look them up if you need to use them. Right, you can see that there's a hyphen variation, there's an equal variation, there's a plus variation, and there's a question mark variation for all of these. Right. So let's just quickly look at these each in turn. All right, so here the expansion is, so str is our variable, right? It's our variable that holds a string. Right? We've got the minus sign here, and then we've got some word. Word is just a string. Okay, so if str is unset, so in other words, if you haven't used str yet, right, then the expansion, so everything here, right, results in word. Right? So if string is unset, replace everything with the string in word. If string is set but it's empty, then just use string, right? So use the empty string. Right? If string is not empty, which means it's also set, right, don't just replace the expansion with the original string. Right? The colon minus variation does something different if the string is empty. Right? So here, if string is empty or unset, replace everything with word. Right? Otherwise, just replace everything with str. So you can see that the hyphen variation is useful for producing values from unset or empty variables. Right? So you've got a variable, it's possibly not set or it's empty. You would actually like it to have a value, right? And so you can assign it a value by probably using this one, right? So for example, you have a script. It expects one or more parameters, one or more command line arguments, right? So command line argument 2 and 3 and 4 and so on. Well, let's say it expects 2 command line arguments, right? But the second one is optional, right? And so you can imagine that in your script, one way you can check is, well, if they passed in one argument, so use an if statement, right? If there's one argument, set the second argument to some value, right? Some default value, right? You can use an if statement, or you can just use this thing here, right? So for example, $brace2, right? Colon minus some default value, right? And so if the second command line argument is empty or missing, right? Give it some default value instead. Right? Question?
What does it mean that
Unset means the variable hasn't been used yet. So for example, so we can do an example of this. I guess we're in strings. Okay, so I'm going to make a little script here. Test. Sorry, this is user bin env bash. Can you guys even? Oh, you guys can't read that. Sorry. Hopefully, I can fire up code from here. Oh, sorry. Okay, so first line of our script, hashbang user bin env bash, or if you're in Linux, you can just use hashbang bin bash. Right. All right, so we have expect a script that has two command line arguments. Oh, sorry, two command line args. Second arg is optional. Right, so imagine this script requires 2 file names, for example, right? So the first file name, so file 1 is $1, right? File 2 is $2. Now imagine that the user did not provide a second command line argument, right? But it's optional, right? So you actually want file 2 to have some default. So you want file 2 to have some default value if the user didn't provide the second command line argument, right? And so the way that you can do that is with the command line substitution. Is with the substitution. So $f2, right? Colon minus, right? So if f2 is unset, or well, it's not going to be unset here, but if it's empty, right? Replace it with something else. So I'm going to replace it with some default value there, like that. Right? So now we can do echo f1. I should quote this because these are coming from the command line arguments, and so they could have some unusual characters in them. Right. So f1 is command line argument number 1, f2 command line argument number 2. If command line argument number 2 is empty, I'm going to set it to some default value instead, and now I'm just going to print out f1 and f2. Right. So make sure I have execute permission on the script. Right. Okay, so test so arg1, arg2. Right, so if I pass it in 2 arguments, the second argument is arg2, right? So f2 is arg2. If I pass it in only 1, right, arg2 becomes some default value that you would pick instead, right? And that's it. So basically, it lets you set a variable. It allows you to assign a default value to a variable if it is unset or is the empty string. Okay, the equal variations are useful for setting default values to unset or empty variables. Oh, the equals variation, right. Okay, so the equals variation does assignment as well. Right? So it's the same as the minus variations, but it also assigns to str in this case. Right? So if str is unset, then this variation and this variation sets str to word. Right? The expansion also produces the string word, right? Whatever word happens to be. Right? So the expansion gets replaced with word, has the side effect of also assigning word to str, which is probably what I wanted to do in the previous example, actually. So we'll use that in just a second. Right? If word is the empty string, if string is the empty string, then do nothing special. Right? Here, if string is the empty string, then assign word to str. Right? So the colon operator, so the plain old operator versus the colon operator also does something if the string is empty. So I guess, using that operator there, right? Notice here, if I'm using colon hyphen, I have to reassign back to F2 myself, right? Instead of reassigning myself, I can just use equals hyphen here, right? And so that will do the assignment to F2 for me, which is probably what I wanted to do in the original example. Okay, so once again, arg2 command not found. Line 8. Oh, does it actually warn you? That's nice. I didn't know that. Line 8, arg2 command not found.
Because you put an extra hyphen after the
Equals something, an extra hyphen, equals, oh, I'm sorry, you're right. There, that's what I wanted. Thank you. Nope, still complaining. What did I do wrong? F2. I typed it in right, didn't I? Colon equals, right? Word assigns word to string, yes. Colon equals some default value. Well, I guess that's something to look up. So I did not know that it actually prints out a warning here, which is probably useful in this case. So it's trying to arg2 command not found. Oh wait, test line 8 arg2 command not found. What did I do wrong? Fascinating. I have a feeling it's doing something funny. Nope, still doing it. All right, I will look into this and see exactly what it's trying to figure out exactly what it's doing. So it looks like it's actually processing. Oh, I'm sorry. What did I just do? So the expansion is. The expansion. Okay, so what's going on? Okay, I've got to figure it out now. All right. So this is resulting in the string arg2, which is what it's complaining about. Sorry, I've got to figure it out now. So I passed it in 2 arguments. So that means the positional parameter number 2 is actually set. So F2 gets set to arg2 in this case. This thing here results in the expansion arg2. So Bash is trying to interpret that as though it were a command, which is not what I want. I just want to do the assignment directly. And so that's what's going on there. So if you don't pass in the argument, it's going to do the same thing. All right. So now it's going to come. All right. So now it's going to replace all of this with some default value. And that's also not what I want. How do I suppress this? So that's what I want to happen, but I want to also assign to F2. I just want to look ahead in the notebook because I have a feeling there is another one that does this. It does not. Okay. So that all results in some default value. Do you have to do the reassignment again? That's very strange. I mean, you can always fix it by doing that. So now the problem will go away. But that looks awkward to me. So this will now work. Oh, no, it still doesn't work. F2 equals, oh, that's weird. Well, that's strange. I don't know what's going on. I can't explain to you what's going on here right now. I have to look it up and play around with it. This looks like it ought to work to me, though. So that is, all of that is producing whatever the second command line argument. So in this example here, that's producing the string some default value, which should be assigning it back to F2. Oh, wait, I didn't save it. Sorry, there you go. Now it's working. Okay. I don't know if there's a way to avoid the reassignment or not. So I'll look that up, and if I can find a solution for you, I will explain it in the next class. All right. Back here, the plus variations produce alternate values from a set variable. So this one is a bit unusual. So if string is set, these do something. So if string is unset, nothing happens, right? If string is the empty, if str is empty, then for the first one, you get back the empty string. Right? If string is empty here, nothing happens, right? If string is set, then you end up with the other, then you end up with word. Right? So these allow you to get a different value if string is set. And then finally, the last two actually write they cause your script to stop. So if string is unset, then it writes whatever this is to standard error and exits. So these would be useful for doing input validation. Right? So if you need, if you are getting stuff from the command line arguments and they're not set, right? These ones will actually, you can have them output an error message when something's not set, right? Or in this case, when something is not set or empty. Right? I don't know what the exit status is for these two, but it's gonna. Hopefully, it's non-zero, right? So these actually write to standard error for you, which is kind of handy, right? So these can be useful for doing input validation. There is a little test script that you can play around with called empty.sh, I think, that you can play around with to experiment with these different substitutions. I guess we can take a quick look at it and see what's in the script. Is it here? It is. Okay, so code. Oh, it's actually a fairly long script. And it uses a function as well. All right, so I guess this is handy. So that's an example of a bash function right there. We're going to look at these in like week 6 of the course. So not super important to understand what this is doing right now. But that's basically a function. This is how you write a function in bash. So what is this one doing? sin is the original input string from the command line. Sout is equal to sin if sin is unset. Otherwise, it's equal to the string unset. Okay, so if the number of this is also using the square brackets. All right, so in the previous class, we talked about arithmetic, and I showed you how to use the double round brackets as a condition. The other way to do this is with the double square brackets. Right, so the double square brackets it's called the test command in bash. So this one lets you test strings and other stuff. It also lets you test numeric values, but it's really awkward to do. So using the double square brackets, that's how you write if the number of command line arguments is greater than or equal to 0. Right? Notice you can't use greater than or equal to. You have to use this minus GT, which is why I told you in the previous class, if you're doing a numeric comparison, use double round brackets. Right? Okay, so if the number of command line arguments is greater than or equal to 0, sin is the first command line argument, right? And sout is, well, the first command line argument. Right? Otherwise, sout is set to the string unset. Right? And now it's going to play around with all of the different substitutions that are in that table and output the result of them. So that's all the rest of it does. Right? So fiddle around with that script and look at the output of the script to see what happens when the variable is either the empty string or unset. Right? The script outputs everything for you. So like that. Right? So here, the first command line argument is unset. Right? And these are showing you what all of the expansions result in. Right? So if your string is unset and you're using the minus, right, whatever word you get word. Right? So all of this results in that. Right? And the value of str remains unset. Right? If you use the colon hyphen variation, right, and the first string is unset, right, then the expansion results in word, right? String remains unset. Right? Here you can see the equals ones, right? So here's what happens when you use the equals and colon equals, right? And you can see that string gets set to word and string gets set to word here. Right? And then there's this one dies because, this one dies, it's supposed to die, right? So this one is testing the bottom two variations, right? And notice what these do, right? So if str is unset, then you get an error message printed to standard error, right? And it exits. So this is doing exactly what it's expected, exactly what you want it to do, right? So here we're getting the error message online, online 58. What is string word? String colon word. You're getting the error message from the, I can't even remember the name of the operator, of the question mark operator here. Right. And so you can play around with the script by passing in, X, Y, Z, for example. Like that, right? And so now string is set. So now it's showing you what happens here. It's showing you the result of the expansion in the middle column, and it's showing you the value of str in the right-hand column here. All right, so that wraps up everything that we want to talk about with regards to strings. So just remember that for the purposes of an assignment, everything is more or less fair game. However, for the purposes of a test, it's only the length of a string that you need to know and obtaining a substring from a string. Right? Everything else is, I don't think it's important that you actually memorize how they all work. Right? All right, any questions about strings or parameter expansion? Okay, moving right along. So the next notebook describes the tr command. So tr is another command. It does string manipulations probably in a way that's a little bit easier to read than the ones I just showed you. So tr is short for translate. Right? So it will perform character by character translation of a string. Right? So in other words, convert a character of a string to some other character. Translation also means deletion. So you can choose which characters you would like to delete from a string. And you can also choose to replace repeated runs of a character. Right? So if you had AAA and you just want a single A, tr will let you do that as well. Right? Typically, you do that to remove extra white space. Right? So you might have A space, 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 B, and so on and so on and so on. Right? You want to replace it with A space B. tr is able to do that. Right? So the way tr works is you've got some options, like every command. Right? And then you pass in at least one string, so that's sequence 1. Right? Sequence 1 is supposed to be a set of characters. So it's a string, right? And the string represents a set of characters. So by set, I mean it's not supposed to have duplicates, but if it has duplicate characters, it's fine. Right? Some variations of TR, you have to pass in a second set of characters. Right? So that's the first variation we're going to look at. Okay. So TR expects stuff from expects its input from standard input, right? Which is a little bit awkward, right? So if you have a variable and you want to use TR on the variable, there's no way for you to TR is expecting its input from standard input. So that means you have to take the variable and print it, right? And so here I'm using printf to do the printing, but you can also use echo, right? So printf is another way to print something in Bash. It's formatted printing. If you know any C, and you've seen C's printf function, then this is similar. It's not exactly the same, but it's similar. Right? So printf, you pass it a formatting string. So here %s means treat the next argument as though it were a string, right? Or print the next argument as though it were a string. So printf %s, and then $x means print the string that's in x as though it were a string. Right? So that prints it to standard output, right? But now I use a pipe to pipe the standard output to the input of TR. Right? So sequence 1, sequence 2, right? So the way this works is for every character in sequence 1, replace it with the corresponding character in sequence 2. Right? So this translates all P's in X to T's and prints it to standard output. Right? So sparring with a purple porpoise becomes starring with a turtle tortoise. Right? Here's that's a Java package. Right? Here I'm going to replace all of the dots with a slash, and so that gets you to the directory containing a particular for a particular package. So the directory containing this package is supposed to look like this as far as the Java compiler is concerned. Right? So your two sets can have any length. Right? So here I'm doing translating a single character to a single character. Right? But you can translate any number of characters to any number of corresponding to the same number of corresponding characters. Right? So for example, you can translate all uppercase letters to lowercase letters, right? Or all lowercase letters to uppercase letters, right? If you wanted to do a very bad encryption, you could scramble up your letters and translate the alphabet, so A through Z, to some scrambled version of the alphabet, and that will give you very bad encryption, right? All right, so here are some more examples. So sequence 1 is the set of lowercase letters A through Z. Sequence 2 is the set of uppercase letters A through Z. Right? X is the string that I would like to translate. So I'd like to make little CISC 220 into all uppercase CISC 220. Right? So convert all lowercase letters to their corresponding uppercase letters. So sequence 1 are the lowercase letters. Sequence 2 are your uppercase letters. And so that converts little CISC 220 to all uppercase CISC 220. Right. So notice here, sequence 1 and sequence 2, they have the same length. Right? That's because you're going to do character by character translation. Right? Lowercase a gets translated to uppercase a. Lowercase b gets translated to lowercase b. And so on and so on and so forth. Right? You run into a problem if sequence 1 has more characters than sequence 2. Right? So for example, if you do that, right, sequence